Okay, thank you for allowing me to be here. It's a great pleasure to join all of you in person and to talk about all of these interesting topics. And I do think that the interdisciplinary perspective and conversation is important for trying to address these issues in a deeper way than we might otherwise have. So my main objective today is to sort of defend and advocate for a perspective about the nature of human language and its evolution and biological instantiation offered by Berwick and Chomsky, most noticeably advocated by Noam Chomsky, I think, over a number of years. And so I think that this perspective can be summarized by a couple quotes here from Noam Chomsky. Whatever emerged along with modern humans and yielded the faculty of language must have been very simple such as some small rewiring of the brain. And furthermore, maybe there's just sort of one language, and he's describing this in a deeper sense, that there's one sort of faculty of language that allows us to generate complex expressions and novel ideas in an unbounded way, but that a lot of the variation that we see in terms of the overt realization of that capacity comes from the process of mapping that system to externalization systems, that is, the sensory motor systems for expressing language. So in some sense, human language is really identified by a deep structural property of creativity and expression, and that acquisition and externalization really are sort of a separate process of adapting that internal system to the process of communication. So basically my whole point of speaking here is to try to sort of advocate for this view. And I think the big reason that I do so is that this is sometimes viewed as quite controversial, but I think that this perspective meshes well with what we know about the neurobiology of language. So I start here with the classical model. I think many of you may be familiar with this model. So this was first advocated by Wernicke and later sort of revived and fleshed out by Geschwind in the 20th century. But the basic idea of the model is that language consists of basically three components, that there's an auditory component, and a charitable interpretation of Wernicke's work here is sort of, this is more about phonological representations, that these are sort of sensory representations that are more specific to language, more abstract. They're sometimes termed auditory word memories, sort of your memory of the forms of language. And that this center is connected to peripheral systems for processing sound, and so the process of comprehension involves mapping sound to this auditory center and then to widely distributed conceptual representations throughout the cortex. And that a second component of language is represented in that circle on the left there, the M, which stands for sort of motor word images. And again, if you give a charitable interpretation, this is something like phonology, but more about the motor expression or your memories for how to articulate and to externalize speech sounds. Right, and those two are connected via a link, which Geschwind later posited was the arcuate fasciculus, the well-known white matter tract that connects Wernicke's area in the posterior temporal lobe and Broca's area in the inferior frontal lobe. And so, and this theory, of course, was entirely motivated by what we would now perhaps see as very coarse methods. Basically, people that exhibited some kind of language disorder, likely following stroke or other kind of incident, and then post-mortem examination of the location of the lesion in their brain. And so these are based basically on case studies with very rudimentary methods, no neuroimaging techniques. But it was actually quite insightful. It seems to be the case now that people sort of dismiss this model as being overly simplistic, the neuroanatomy is wrong, the linguistics is primitive and not what we know about language today. But in many ways, the theory was very compact and predicted the existence of aphasia syndromes that had not yet been discovered. And as sort of, with a few small set of interacting components, was able to explain receptive linguistic deficits, expressive linguistic deficits, and deficits that had various features of both. But of course, this model is in many ways incomplete. As I mentioned, the neuroanatomy is still overly simplistic, and it does not incorporate what we really know about the nature of language that has come about after decades of research. So this image here represents a more modern view. I think this is a fairly common perspective. And you notice here that some of the words used to describe the model are not just expressive and receptive, language stuff, but rather things like phonological articulatory processing, hierarchical syntax, semantic processing, local combinatorial processing, and so these incorporate more higher-level linguistic notions, okay, encompassing the fuller range of what we know about language. And a key aspect of this model, which I think is a view that is widely shared, is that Broca's area in the left inferior frontal gyrus is basically the key region responsible for this hierarchical syntactic processing, and that lexical representations are stored in the temporal lobe, and basically you sort of build sentence structures by combining those lexical elements using computational machinery that lives, in a sense, in the inferior frontal gyrus, or Broca's area. So I think this is a fairly standard view, and a view which I'm going to dispute, and articulate an alternative view based on newer sets of data. But the sort of motivation, a lot of the motivation for this perspective came from aphasia, and in particular the syndrome of expressive agrammatism that we see in a very common type of aphasia known as Broca's aphasia. So Broca's aphasia is known as a non-fluent aphasia. The characteristic deficit is one of speech production. So typically you would see what looks like impaired production with preserved abilities of comprehension. And so a common symptom of Broca's aphasia is what's known as expressive agrammatism. And so, for example, this is an individual here. This is actually someone who is an actor. His name is Carl. There's a great movie called Aphasia the Movie about his experiences with aphasia and recovery. But he's trying to explain why certain words are difficult for him to produce. And he says, small words, no pictures, but cat okay, cat fine. Right? And actually you see there on the left, there's like a list of what we call function words, these things like prepositions and WH words, the word is, right? And so those, he says, are difficult. I don't know what they are. But he takes draws a C in front of the word at and says, well, that one, that's fine. All right, so typically we define agrammatism as the overall tendency to omit function words and morphemes, sort of telegraphic speech, and overall simplified sentence structure, which you can see exhibited there. And so, so a big motivation for the sort of view that Broca's area is important for syntax comes from the sort of tenuous association between Broca's aphasia and damage to Broca's area. And right, this is one of the original discoveries in the history of aphasia, was Paul Broca's patients that had severely limited speech output, and later on was again emphasized this connection between damage to Broca's area and expressive agrammatism. And so the idea is that perhaps this tells us something about the localization of syntax in the brain. You have difficulty producing syntax, we assume you have damage to Broca's area. Right? The question that comes about with modern techniques is this really true? Is this association actually the case between expressive agrammatism and damage to Broca's area? We know the situation is in reality more complicated. You don't necessarily have to have damage to Broca's area to have Broca's aphasia. You can have damage to Broca's aphasia and not have, you can have damage to Broca's area and not have Broca's aphasia. So we can do modern lesion symptom mapping analyses here where you take a subject's MRI or CT scan, and you can draw the areas that are damaged and map that to a standard template and then perform group analysis in a similar way as you would do for any other kind of neuroimaging data, for example, functional MRI, or really any other kind of method, right? So now we can actually derive a quantitative relationship between a particular behavioral deficit and damage to particular regions of the brain. So it actually turns out, using modern methods, that it's true. The assumed story from before actually turns out to be true, that there is a relatively strong relationship between damage or degeneration to Broca's area and expressive agrammatism. Okay, and this has now been shown by a variety of studies using this lesion symptom mapping technique. Okay, so that seems to be true. The story is great. Expressive agrammatism, damage to Broca's area, syntax lives in Broca's area. Story's done, let's go home, question solved. But what's interesting here is, again, the original observation about Broca's aphasia was that this is a purely expressive deficit, right? And the traditional observation was that these patients are very good at comprehension. And so if they're very good at comprehension, we would assume that they probably have some kind of intact syntactic representations that can guide that comprehension, right? And a seminal study in the 20th century by Kermatza and Zurif basically questioned that notion. And so they presented a variety of sentence constructions, basically subject and object relative sentences, and they importantly manipulated what's called the semantic reversibility of the construction. So that first example sentence, the girl that ate the apple is tall, if you were to ignore the syntactic structure of the sentence and only looked at the lexical semantics, you could reconstruct an interpretation given your understanding of world knowledge and the plausible relationship among entities, right? So apples can be eaten by girls, so they don't tend to eat girls, right? But if you look at that last example, the girl that the boy chased is tall, these are reversible, right? So you've got a girl and a boy in a chasing relationship. There's no strong overriding real-world plausibility for one interpretation or the other. And given that this is a non-canonical sentence in which the girl is actually the subject of the embedded verb chased, you have a sort of a non-canonical mapping, right? So a heuristic by which you might guess at the interpretation of the sentence would fail unless you were able to use the more detailed syntactic structure of the sentence to guide your interpretation, right? And it turns out that people with Broca's aphasia actually struggled quite a bit on those types of sentences, right? So this was a very important study in many ways because it established the seeming, what's called overarching agrammatism hypothesis, the idea that damage to Broca's area causes parallel deficits in both production and comprehension, which pointed more strongly to a sort of overarching syntactic ability in Broca's area, a central syntactic ability, which is really the main point of a lot of linguistic theory to suggest that we have central systems that underlie multiple behaviors, multiple ramifications. But the problem here is that there's a lot of assumptions that are built into this study. So, for example, subjects could fail at comprehension of certain sentences for other reasons aside from syntactic processing. This is a well-known issue, and Christoph addressed that in the neuroimaging studies that use similar kinds of constructions. They might invoke things like working memory or other executive function resources. And another issue is that people with Broca's aphasia were not the only ones to struggle with the interpretation of these kinds of sentences. It turns out that people with conduction aphasia, which is typically conceived of as a fluent aphasia, people that have impaired comprehension and more intact production, actually also struggle to interpret these sentences. So now the question is, what happens when we look at the modern lesion symptom mapping approaches to receptive agrammatism or syntactic deficits in comprehension using this kind of approach? So this is a study we did using the lesion symptom mapping technique. And on the left of that image there, I'm showing you the results for a very similar syntactic comprehension measure as in Karamazov and Zuref. Here we're looking at a variety of object-first non-canonical structured sentences. All of these are reversible, where both the agent and patient are plausible agents of the verb. And we basically control for lexical processing using a simple active sentence comprehension, and then we look at the residuals for these more complicated sentences that seem to require syntactic abilities, perhaps among other things like working memory. What we find basically is that this is entirely associated with posterior temporal damage and not to the inferior frontal lobe at all in this study. Right, and by contrast, if we look at agrammatism using similar methods as other people have used, we replicate those previous results and we show that agrammatism is mostly associated with frontal damage and not temporal damage. So these things appear to pretty strongly doubly dissociate. Now, I guess the question we might be asking is this really the best measure of syntactic comprehension? And I would agree that not necessarily the case, right? These non-canonical sentences do involve other things aside from syntax, likely involving working memory or other kind of decision-making resources to deal with a sort of less frequent and more difficult structure. But if you look at this in a variety of ways, these are all studies from different labs. On the left is very similar as to what I just showed. They look at non-canonical performance with canonical performance as the covariate, same result, posterior temporal damage and not inferior frontal damage. On the right, the upper right there, that's a study from Pillay and colleagues, which looked at a different measure. This is basically complex sentence comprehension, but without these non-canonical structures, using picture naming as a covariate, again, finding posterior temporal damage and not Broca's area. And in the bottom right, it's actually one of my favorite studies that's never cited, but Stephen Wilson and Sagan, they looked at acceptability judgments, right? So they actually presented an interesting array of different sentences, grammatical and ungrammatical, and then did the same analyses, right? Where are lesions associated with deficits on a syntactic acceptability judgment task? And again, it's entirely posterior temporal lobe and not frontal lobe. And so it seems like, and we've been actually working on replicating that study with acceptability judgments. We have about 20 subjects so far. It's preliminary data, but we look at a range of constructions We look at word order violations, agreement, and subcategorization, and we basically find the same result. It's posterior temporal damage that predicts deficits and not Broca's area damage. Okay, so basically something to do with syntactic comprehension is in the posterior temporal lobe, right? But one of the original motivations for this dichotomy of localization between syntactic computation in the frontal lobe and lexical computation in the temporal lobe is the idea that these things are sort of two distinct, categorically distinct aspects of language, that basically you don't want to have localization of these functions to the same area. But actually, I think this assumption is flawed for a variety of reasons. One is that all linguistic theories essentially postulate that lexical items must be associated in some sense with syntactic structure. You can look at generative grammar, for example, X-bar theory or subcategorization. These are all aspects of syntax that must be associated with particular lexical items. If you look at the psycholinguistic literature, right, when we often talk about what's called a lemma, this is a notion basically of the syntactic expression of a word or the syntactic representation of a word. And indeed, it doesn't, some good work by David Popel and David Embick discuss the complexity of mapping cognition onto the brain, and Christoph talked about this in his talk. It's not obvious exactly how the representations and computations of linguistic theory map onto the brain, and it need not be the case that a computation such as merge is associated with its own distinct cortical area from the lexicon. In fact, it could be a very convenient organization to have lexical items stored in a particular brain area and the merge operation operating over those lexical items in some way via mechanisms such as cortical oscillations or other kind of sub area mechanism. Right, so I think it's actually reasonable to suggest that the syntactic computations, along with the lexicon, sort of live in the posterior temporal lobe. Okay, but this makes a prediction, right? So again, we don't want our syntactic theory to be purely there's a syntax for comprehension and a syntax for production. Obviously, these things are systematically related, and so we would expect that if it's true that basic syntactic computations are associated with the posterior temporal lobe, damage to this region should produce production deficits as well. Everything I presented so far suggests that syntactic production deficits are associated with frontal lobe damage. So we actually decided to look at this in more detail. So one of the early neurologists looking at aphasia, Kleist, he wasn't the first to describe agrammatism, but he actually postulated that there are two categorically distinct ways in which the production of language in people with aphasia could be disturbed at a grammatical or syntactic level. So the first is agrammatism, which we're familiar with and many researchers have looked at over many decades. But the second was called paragrammatism, and I'll just read the quote translated from German. The ability to create word orders is not abolished in paragrammatism, but phrases and sentences are often wrongly chosen and thereby amalgamate and contaminate each other. Phrases and sentence constructions are not completed. The spoken expression is not simplified overall, instead also conditioned by a strong overproduction of word sequences. It swells to confuse sentence monsters. And so the idea here was that there wasn't an absence of, in some form, syntactic content, but rather that there was a disorder or disruption of the coherence of the syntactic structure. So then basically, because we thought, we had the hypothesis that syntax is associated with the posterior temporal lobe, we thought perhaps paragrammatism is associated with damage to the posterior temporal lobe as well. And this just hasn't been looked at as much because of the heavy focus on agrammatism and Broca's aphasia. So basically, we just decided to look for that. And how we did this is we took people with aphasia. They undergo a standard language battery, which includes describing the Cinderella story in their own words. So they retell the story of Cinderella in their own words, which allows us to obtain a sort of spontaneous, uncontrolled speech sample. And then basically, we did this in an old-fashioned kind of clinical way. We had expert raters that were to assess each subject's sample as, did it look like they had agrammatism, paragrammatism, or no grammatical deficit, right? They might have other deficits. For example, it's very common for people with aphasia to have what's known as apraxia, or more of a phonetic disturbance to speech output, but we weren't classifying that. We were focusing on the grammatical level. Right, so this is ended up being a consensus rating among 4 raters regarding whether each subject was agrammatic, paragrammatic, or no deficit. And actually, we did identify 4 people that seemed to exhibit features of both, but I'm going to put that aside for now. So we ended up with 53 people that we could successfully classify into these categories. And many subjects we couldn't classify because they had a severe disruption to their speech intelligibility, or there was some other issue. For example, they just refused to produce a large sample, or there was some technical issue. So just to give you some examples of speech output that we identified as paragrammatic, we didn't do an exhaustive systematic analysis, but these are just some examples. Like, for example, a 3 other sister. He had to do all the works. Wanted to make a trick her. This is an interesting example, sometimes called a fusion example. The verb trick here is being used as both a noun and a verb in the same construction. She goed back to the boy. It's an over-regularization. You might see that in child language, but typically not in adult language. 1 stepfather and a stepchildren. And the agreement errors I do find particularly interesting in paragrammatism. These are things you don't typically see in agrammatism. You don't typically see overt agreement errors in agrammatism, but you do see that in paragrammatism, even for things that are locally adjacent. For example, a and stepchildren. And then thus some happen to them. There's like a sort of a duplication here of a determiner. Okay, so basically when we do the lesion symptom mapping analyses, we look for lesions associated with agrammatism, lesions associated with paragrammatism, and we always incorporate lesion volume as a covariate. It turns out that people with Broca's aphasia tend to have much bigger lesions overall than other types of aphasias, so we're keen to control for that. But basically we find a double dissociation. Agrammatism, replicating previous studies, is associated with frontal damage and not temporal damage. Paragrammatism is associated with posterior temporal damage and not frontal damage. Right, so this confirms our prediction that we would find some disturbance to speech output with respect to syntactic structure in people with posterior temporal lesions. And one thing that's important to note, there's a big difference in terms of speech rate. People with agrammatism tend to also produce fewer words and less quickly, right? So a lot of people have asked this question as to, is there really a fundamental grammatical distinction? Is it purely just the preponderance of speech in fluent aphasia and the paucity of speech in agrammatism that really governs the distinction, and that they might share some similar underlying grammatical deficit? But when we control for speech rate, we basically find the same results, right? And actually, I don't show this here, but people with paragrammatism actually tend to have a higher speech rate than those without any grammatical disturbance. And so this confirms what Kleist had suspected, which is not only do they produce disturbances in their speech output, but they actually produce more speech than people that are healthy or don't have a grammatical deficit would produce, right? Okay, and then this is just to show, this is another measure of syntactic comprehension. This measure is the sequential commands subtest of the Western aphasia battery. And this subtest basically asks subjects to perform a variety of simple tasks, like with the pen, touch the book. And they vary the syntactic structures such that you would have to be able to reconstruct the relationship among the items in order to correctly perform the action. And then we include word comprehension as a covariate. So basically we're trying to look at syntactic comprehension. And we find no relationship between agrammatism and syntactic comprehension deficits, but we do find a strong relationship between paragrammatism and syntactic comprehension deficits, right? So the overarching agrammatism view is sort of not correct, right? Patients with expressive agrammatism, there's no relationship to their receptive deficits. They might occasionally have deficits, but there's no systematic relationship. Actually, what seems to be true is something more like overarching paragrammatism. Damage to the posterior temporal lobe seems to produce deficits in both production and comprehension of syntax, right? And then this is actually hypothesis of Wernicke. He was talking about, again, the sort of phonological level, but his idea was you see errors in fluent aphasia because you lack the monitoring of your own output that you would have otherwise, right? When you damage the auditory word center, you're sort of unable to catch the errors in speech output using your internal representation of that speech sound. So it seems like we're seeing the same thing at the level of the sentence or syntactic structure. Okay, how does this relate to the minimalist program and to the thesis of Chomsky and Berwick? Well, the whole point of the minimalist program in many ways is to reduce the complexity of the innate aspects of language that are encoded in UG. So this basically ends up being reduced to primitive atoms of combination, roughly words, but obviously not quite, and a simple structure generating mechanism that is called merge, right? That is sort of inherently or intrinsically linked to semantic interpretation or the computation of meaning, right? And the idea is that there's no linear order in this internal computation, right? And then this is sort of the human unique aspect of cognition that leads to the ability, the human faculty of language, right? Now, of course, part of that thesis is, well, you do have to say things out loud, right? We end up communicating, we do end up expressing language externally. And so what this is, according to this hypothesis, is sort of a co-opting of sensory motor systems for the externalization of these hierarchical structures, right? And so you can think of, and this is a nice proposal by Itzardi and Ramey, you can think of this externalization process as a series of stages of essentially converting a hierarchical representation without linear order to a fully linear phonetic representation through a series of stages. So for example, morphosyntax, morphophonology, and phonology. Right, so this idea in many ways I think fits with the data that we have from aphasia and motivate a model of language in the brain that sort of looks like this. Okay, so this is a model that I recently published with Gregory Hickok, sort of an extension of the dual stream model, if you're familiar with that terminology, at the level of syntax. And so a core aspect of the dual stream model is that you have divergent systems for processing different aspects of language. The ventral stream and the temporal lobe underlies both comprehension and production, as the frontal systems are mostly associated with production, but may be used in some circumstances, for example, for working memory to support comprehension, but are not intrinsic or necessary for comprehension in most cases. All right, so you can see here there's a green area in the posterior superior temporal sulcus, middle temporal gyrus, that we believe is associated with hierarchical syntactic abilities. Again, the motivation for that from the perspective of this study is the fact that you damage this area and you have deficits in comprehension of syntax as well as paragrammatism. And the yellow area, at basically the anterior portion of Broca's area, we think is responsible for the sort of first aspect of the linearization transformation. And there's a lot of other research suggesting an association between the frontal lobe and sequencing and motor abilities. So we think this is essentially a more abstract version of that at the level of morphosyntax with increasingly detailed phonetic information as you go posteriorly towards motor cortex. Right? And the arcuate fasciculus, the white matter tract connecting the two, essentially affects this initial hierarchical to linear transformation. Right. So, going back again to the Berwick and Chomsky thesis, the idea is that most of what language acquisition is the acquisition of externalization procedures. Again, of the sort of co-opting of these pre-existing abilities for sequencing and linearization for linguistic representations. And this fits in some ways with what we know about language acquisition, in that children, this is a nice paper by Gagliardi et al., who is present with us, basically looking at a variety of experiments of comprehension, sentence comprehension in young children. And then basically by 2 years or so, these toddlers seem to have acquired what is almost an adult-like syntactic competence in terms of argument structure and filler gap dependencies. But of course, we know that production lags dramatically behind those abilities. So children by 20 months old are producing at best single words and nowhere near the level that seems to be true of their comprehension abilities. So again, this suggests that there's a prolonged, protracted process of language acquisition, which essentially is figuring out how to produce stuff, figuring out how to relate the hierarchical information that they have innately in order to actually produce an overt phonetic expression, right? Figuring out the morphosyntax, morphology, phonology, et cetera, of their language. And so some support for this distinction here, this is work by Ghislaine Dehaene-Lamberts, looking at the morphology of various parts of the brain, and basically finding that in the left superior temporal sulcus, close to the area that we think is important for hierarchical syntax, there's a pretty robust leftward asymmetry in terms of the depth of the sulcus. And this could be due to a variety of reasons. One, for example, could be increased white matter connectivity of this region, but it seems to be the case that nearly every human that was studied in this experiment, or in this study, showed this pretty robust leftward asymmetry, right? Present in adults as well as in infants, not long after birth. That the sulcus on the left is deeper than on the, more shallow than on the right, right? And this is not present in other animals such as chimpanzees or macaques. Right, so this seems to potentially reflect this innate hierarchical ability that is congruent with the merge, or the sort of basic property of language. Right? By contrast, what I'll show here is that the arcuate fasciculus, this white matter tract that connects the posterior temporal lobe to the frontal lobe, has a protracted developmental period. So the strength of this tract is not fully present in infancy and doesn't fully connect the posterior temporal lobe to Broca's area proper, and that only emerges after several years of development. And so again, this suggests that basically what's happening is that children are co-opting their frontal lobe for externalization, and this is reflected in increasing strength of connection to relate the hierarchical information in the temporal lobe to Broca's area. Right. And again, I think it was discussed the first day by Nama Friedman about the critical period, but the idea of the critical period is that without exposure to early language input, language acquisition is severely impaired, and at the level of syntax might even be nearly impossible. And a lot of the motivation for that perspective of the critical period, the L1 critical period, comes from the study of Jeannie, who was a child I'm sure many of you are aware of, was abused and basically not talked to by her parents for many years, and when she was discovered as an adolescent, was unable to learn beyond the level of the lexicon, essentially, for language. Of course, there's a lot of confounds with Jeannie, namely the severe abuse and malnutrition and other issues, but a population that is actually well studied at this point are people that are born deaf to hearing parents. And so, without going into too much detail, people that are born deaf, obviously, if their parents are hearing, which is the majority of situations, are sort of naturally deprived of input from their parents. Now, living in a country like the United States or France, there are schools for the deaf, there are programs for instruction to ensure that the child is not deprived of language input. But in some countries, in some situations, this still occurs, and there's actually a broader population than the single subject of Jeannie. So this particular study looked at 3 of these individuals who were not exposed, deaf individuals who were not exposed to language until adolescence. They were immigrants to the United States, and then as adolescents or adults, in the case of the example Martin, were finally enrolled in schools for the deaf to instruct them in ASL. And they showed a rapid lexical development and basically minimal, if no, development of syntactic knowledge, very similar to what was seen with Jeannie. Interestingly, if you look at neuroimaging of these individuals, it turns out that their left arcuate fasciculus shows a much less degree of strength of connection compared to deaf native signers of ASL or hearing speakers of English. Right? So again, it suggests that this connection between the temporal lobe and the frontal lobe depends on early exposure to language data and pressure, communicative pressure, in order to link sort of basic hierarchical property with externalization systems in the frontal lobe, right? And without that early pressure, that early input, that doesn't develop. Okay, so to sum up, the separation that the minimalist program postulates between hierarchical structure and linear externalization that attempts to, in many ways, deal with what seems to be the recent emergence of human language is roughly consistent. I don't want to claim that this is robustly supported by the evidence, but rather that this is a very consistent scenario. There seem to be 2 language zones, so to speak, in the brain that are critical for syntax, the posterior temporal lobe and the inferior frontal lobe, but these have different properties. The posterior temporal lobe seems to match with a hierarchical ability that's important for both production and comprehension, whereas the frontal lobe seems to be about the expression, the linearization of language, but damage to this region does not impair the basic hierarchical abilities. So this seems at least consistent. And again, the other data that I presented from other labs, looking at the human-specific morphology of the left STS, that again is consistent with the human-specific computational property, in Chomsky's words, some small rewiring of the brain, and again, the details of which are unclear, but somehow are associated with a change in function of this region that enabled the property. And again, the prolonged development of the left arcuate is consistent with a process of, for example, neuronal recycling of frontal sequencing mechanisms for externalization of language. And with that, I'd just like to acknowledge some of my co-authors and people that I bounced these ideas off of.